Hello, this is Keith Graham from Codasip. I would like to talk to you about the bit size macro. You'll be using that in your cycle accurate processor model for automation. And the benefits of automation, it improves your efficiency, but more importantly, it also reduces errors. So what is the bit size of macro? It returns n, which makes the following equation true. 2 to the nth is greater than or equal to x, where n minimum is of 1. So n has to be no less than 1. So the formula actually will be evaluated based upon the following. For x needs to be greater than or equal to 1, but if the number is 1, it will be 1, even though the formula of log 2 to the 1th is 0. Now for any number greater than 1, it will be evaluated as log 2 to the x power, and then if there's any number to the right of the decimal point, it would be automatically rounded up. Now as an example, let's take a look at where x equals 2. Log 2 of 2 is 1, and that has nothing to the right, so n will be 1. Now on the other hand, 3 log 2 to the 3rd power will be 1.585, and so the number needs to be n of 2. So 2 to the 2nd power is 4, which is greater than or equal to 3. Now, how would we use this, or why would we use this? This is a common macro that you're going to use to generate the size of your bit signal for your select lines for a multiplexer. If we take a look at a multiplexer here, we have 1 to the n number of inputs and an output, and you have the number of select lines that you need to evaluate the inputs. Now, as I'm adding inputs to this multiplexer, my number of select lines will need to change. For example, if I have 2 select lines or 2 inputs, I only need 1 select line. But as soon as I go up to the 3rd input, now I need 2 select lines. So we will use this in defining or declaring our signals, in particular for our select lines of our multiplexers. Now let's take a look at how this looks like in your cycle accurate model in defining the size of your resources. Now I'm going to take a look at this particular example here, where we're looking at the bit size of my source 2 mux that I'm going to use for my ALU. Now, this is actually defined in my CA model under includes and CA defines.hdcodal. Now, we take a look at our resources here, and I open my CA resources. I'm going to include that particular hdcodal file, which means that when I go through my resources, I'm going to evaluate that hdcodal file before I go and evaluate everything in my resources. Now, if I scroll down on my resources, on this particular line, I have my ALU select lines for my source 2 operand for my ALU. So as I change my number of inputs to my mux, it will automatically evaluate the number of bits I need for my ALU selection. Once again, I'm automating the process, and by automating the process, I will improve my productivity and reduce the number of errors. Hopefully this video was helpful for you. If you like it, please subscribe to this channel so that you'll be updated when additional videos are published, and good luck.